Howdy folks, Tom Bubbly here once again. So I'm thinking of changing the name of the compiler, or at least the thing that gathers resources. GGCC is a bit of a mouthful, and it's also something that I think, there's other GGCCs and it's very close to GCC, so, it's not ideal as it is currently. The reason I started doing this implementation was actually to take my simulation work from the Ape SDK and move it into something that could be compiled to be generic but also still reside within the Ape SDK. And I'm starting that. The random was the first part of that. I'm not sure if I've demonstrated or talked about random. But the next part of it is actually getting the random. Let's open one of these things and show it just to give an indication. So this is what I'm now doing with the landscape, specifically landscape. So basically what this does is it creates a fractal landscape on topography, and the date and time I'm going to put in, the tide level I'm going to put in easily. But the first part was just getting the random number generator. Now this is not quite the Ape SDK random number generator. I'm going to actually put this back in the Ape SDK, so this will be the new random number generator. I have a friend who's utilizing this, shout out to Mike, for random number generation specifically. So I wanted to write some code to make sure the random number generation actually provided the right histogram. So that's what you'll see when you run the code, is it's actually doing a count over, in this case, 16-bit space, and then making sure that the histogram is equal over the 16-bit space. So pretty text impactful, and lots of actual lines of code being, or lines of numbers here, histogram numbers being printed out. So I've added the fractal landscape part, which makes the fractals. I still need to add two additional parts, which does the rounding and then swaps the tiles between them. The tile is the underlying concept. I've stripped that out and just made it the land here. So you get the topography straight from the land. Anyway, so that's what the code looks like now. And it will run and compile. So if we do here, land dot, I should probably show what land.sh does. sh does, let's show what land.sh does before I actually run it. So this basically takes the underlying land file, compiles GCC for a start, then creates the land output, makes sure the C compiles, generates that output, then goes through JavaScript, Python, and finally Java, and make sure that the stuff that's compiled is actually compilable and executable. So that's what that does, and let me run it here. So it's generated the code. It's running, I think, the Python version, potentially. You can tell based on the, so what's it done? It's done the Python version. Let's go back to this one just to see what it's done. So per the original statement, it outputs the land from the C, then does the JavaScript, then the Python, then the Java, and then cleans it all up. Well, actually, it leaves the created 3 files here that you can interrogate if you're so interested. And the aim is to put the next 2 pieces of the land code in, and then make a advancing land, which will advance the date and time and do all that related stuff. And once that's done, I think probably doing something associated with the social graph output, or something just really quite interesting and introspective, is the next part, or at least something that can show emergence relatively quickly, which is the whole purpose of the Ape SDK. Anyway, so Tom Bubbly in Las Vegas, Nevada, just providing another overview, signing out.